This is Mrs. O'Neill for AP Chemistry, Chapter 11, Section 2, Part 6, Ion Dipole Forces. Now, first I want to take note that this is actually the first time we're talking about intermolecular forces between two different substances. So far, LD, dipole-dipole, and hydrogen forces, we were talking about a whole bunch of the same molecules in the same pot. This time, however, we're talking about an ion coming from an ionic compound that splits apart into ions, and, excuse me, and the dipole force like water. So we're really dealing with something like salt water, an ionic or strong electrolyte, an ionic compound in water. So the ionic compound breaks apart into ions, and what's the attractive force between those ions that break apart and the water molecules that stay as a molecule that surround those ions? So again, I am telling you the four major IMFs in order of strength. The weakest LD, a little stronger dipole-dipole. Those are all those polar molecules. Then we go to hydrogen bonding, and hydrogen bonding is still polar molecules, but it's so polar that they're almost ionic because of the size of those atoms and the electronegativity that the hydrogen and nitrogen, oxygen, fluorine form together. So that's why it's in its own category. And please, please, please make sure you're understanding that even though it's labeled as hydrogen bonding, it's really not the bond between the hydrogen and the oxygen in the water molecule. It's the hydrogen from one water molecule attracted to the oxygen of another water molecule. So it's still polarized, polar molecules, but it's in a different class, and that's why they call it hydrogen bonding. And now this section is dealing with ion dipole. So again, this is the only one. This is the first time we're really talking about an ion coming from one substance and the dipole is a different substance. All these other ones had the same substance in the pot. So pause the video, fill in the words, again, read as you write, and then play to hear my words. So just like I said, this is an ion dipole. It's an ion and the attractive force it has with a polar molecule. Remember, a dipole is just a pole that has two ends. That's where the di comes from, and those ends are different, right? One's positive, one's negative. So it's the interaction between those two substances. So this is what it looks like. So we have our water molecule. The positive cation is going to be attracted to the negative part of the water molecule, and the chlorine anion, right, the negative chlorine anion is going to be attracted to the positive hydrogen ion there. So again, this is kind of what's going on. The negative water molecules are going to surround the Na plus ion and going to kind of rip it away. And the same thing happens here. The positive from the water molecules is going to rip away that negative chloride ion from the salt. And we've seen this before in chapter 4, but now we want to make sure you're understanding the force of attraction that those ions and water molecules have. So again, pause the video, make sure you have some kind of drawing in your notes that shows the difference between the positive end and negative end and positive end. So pause and make sure you have some kind of drawing there, as well as make sure that you label that ion dipole force. So that first picture there didn't really show the force of attraction between the positive and the negative. So make sure you have some kind of labeling of that ion dipole force as to where it actually is. So if we have this question for you, they're both in water. So now you have to think about, again, what type of compound is this versus what type of compound is that? Only one of these is really going to have an ion dipole force of attraction. So hopefully you understood that calcium nitrate is an ionic compound, so it's going to be a strong electrolyte, which means it's going to form ions in solution. It's going to break up into those ions and then, of course, be attracted, make those ion dipole force of attraction in the water. So hopefully that makes sense to you, and we'll see you in class for some bookwork.